Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. Now I think it's challenging because that's the difficulty level that the setter gave it, but this is not currently on Logic Masters Germany forum, so take that with a grain of salt. It was given 5 difficulty levels out of 10 by the setter. And today's puzzle is called Storm Surge by James Sinclair. And this was actually requested by a viewer. So we'll go about it and try to solve this puzzle. Here are the rules. Normal Sudoku rules apply, and all clues are standard. Normal Sudoku rules means that the digits 1 through 9 appears once each in every row, column, and box. Arrows. The sum of digits along an arrow is equal to the digits in the connected circle. So therefore, these two digits must add up to whatever that is. So as an example, this could be 2, 6, and 8, because those two digits add up to what that digit is. In addition, you have these three arrows, right? So these three digits would have to add up to whatever that digit is. These three arrows would add up to what that digit is, etc., etc. And you have thermometers, where digits on a thermometer increase from the bulb. So basically, an example that would work here would be 2, 4, 5, and 8, because it's continuously increasing from the bulb to the tip. Now, if this were, say, a 9, this would not work, because the 9 would be decreasing from the 9 to the 8. Or say this was like a 3. This would not work, because then the 4 would be decreasing to the 3, even though the 3 is increasing to the 8. It has to be always increasing all along the thermometer. And find more puzzles like this at artisanalsudoku.com. We found this one actually from Artisanal Sudoku, and those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so I like to do with thermometers is start from the bulb, go to the tip, and start from the lowest amount that you could have, and then find the highest amount you could have from the tip, and then go back to the bulb. So the way I do this is go 1, 2, 3, and 4, 5, 6, and 7. The highest this can be is 9, so this is 7, 8, or 9, which means this can be at most 8, so it's 6, 7, 8, which is 5, 6, 7. But we know if you have 3 digits along a arrow, which sum to another digit, you can have at most a 6 along that arrow, right? Because you can have 6 with 1 and 2, which adds up to 9. And those are the only possibilities. Therefore, this can never be 7, so this is at most 6, which makes this 5 or 6, which makes this 4 or 5. Therefore, this is 3 or 4. This is 2 or 3, and this is 1 or 2. Now, because of that, we know this has to be an 8 or a 9, right? That's why I like going along the thermometer from the least amount to the most amount and then back down, because that gives you things you can actually eliminate, essentially. So we know these have to be 1 through 3, because if you have 3 digits that add up to another digit, 3 unique digits adding up to another digit, you know that you have to have 2 digits from 1, 2, or 3, and then 1 from 4, 5, or well, the other one could be another 1, 2, or 3, but you have to have at least 2 digits from 1, 2, or 3. And since this is 5 and 6, we knew that it could only have 2 digits from 1, 2, or 3 from the rest of the cells. Anyways, we know that this cannot be any more. This can also only have, since we have a 3 or 4 here, you can never have 6 in any of the rest of the cells, right? You could have 1, 5. It could be 1, 5, and it would specifically have to be, if this is 3, this would be 2, and this is 1. So then this would have to be 1 and 5 if that were the case. Otherwise, you could have a 4 somewhere along here, And you could have 2 and 3 also along here, too. This could be 4, 2, and 3 there. That would be fine. In addition, we know of if for these digits, we cannot have anything but a 1, 2, 3, 4, 1 through 5. You can never have 1, 2, and 6 because that would eliminate all possibilities for this cell. So, and why don't we go along the thermometer here too? So let's try that. So this would be 1, 2, 3, 4, 5. This could be 5 through 9, 4 through 8. This again cannot be 3 through 7. It cannot be 6 or 7 in this case. So it's 3 or 4, 3, 4, or 5, right? Because it can't be 7 because you have 3 digits adding up to another digit. And it can't be 6 because if we try to make this 6, this would have to be 1, 2, and 1, 2. And that would eliminate all possibilities for that cell. So this is 2, 3, or 4. This is 1, 2, or 3. Why don't we continue with this then? This is 1, 2, 3, 4. So this could be 4 through 9. This cannot be, obviously, it cannot be 6 or it cannot be 7 or 8, but it could be 6 still. This is 2, 3, 4, 5, and this is 1, 2, 3, 1, 2, 3, or 4. Now the thing is, if this were a 4, that would force this to be 5, and that would eliminate all possibilities for that cell here. So this can never be 4, so that we can limit things even more that way. These can never be 6, because if they were 6, what does this become? This becomes at least a 3, which means that you would have a 6 and a 3, and at least a 1, which would add up to 10, which is not a digit. Therefore, this can never be 3. Sorry, this can never be 6. So this is 1 through 5. This is 1 through 5. Similarly here, these can never have a 6 again. So this could be 1 through 5. And this is 1 through 5. So we know this is 6 through 9, this is 6 through 9, and this is 6 through 9. We also know all the other cells in row 7 must be 6 through 9 because we have a 1 through 5 quintuplet in that row, which eliminates 1 through 5 from the rest of the cells that are not in this quintuplet. So this is 6 through 9. These are 6 through 9. Let's see. What does that tell us? Not much, though. If... If this is 4, this becomes 5, and this is 6. Therefore, this would be 1, 2, 1, 2. So, say this was 7. If this was 7, this would be 4, 2, 1, 4. This still could be 1, actually. That's fine. Actually, no. We know what this is, actually. So this is 1 or 2. We know there are 2 digits here that have to be from 1, 2, or 3. Because again, like I said before, if you ever have 3 digits, unique digits, adding up to another digit, you know that 2 of those digits have to be from 1, 2, or 3, right? Because if say there wasn't 2 digits from 1, 2, or 3, what's the smallest number that you have 1, which is the smallest of the 1, 2, or 3, and you would have 4 and 5 because you can't have another digit from 2 or 3. That would mean 1 plus 4 plus 5, which adds up to 10, which obviously is not a digit. Therefore, you have 2 digits here that are from 1, 2, or 3. Therefore, since 1 is here, and 1 digit from 1, 2, or 3 is here, and 2 digits from 1, 2, or 3 are here, this cannot be from 1, 2, or 3. So this must not have a 1, 2, or 3. It's a 4 or 5. If this were 4, this would add up to at least 5 and 1 with it. So therefore, that would add up to 10, which is not allowed. Therefore, this can never be a 4. This has to be a 3, which makes this a 2, which makes this a 1. Therefore, this cannot be 2 or 3. It can't be 4 either, because then that would add to a 12. Therefore, this has to be a 1. So therefore, this is 8 or 9. Now, this one means you cannot have a 1 in one of these cells. What's the minimum you can have here then? It's 2, 3, and 4, which would add up to 9. So this is a 9 then, and it adds up to specifically 2, 3, and 4, because 9 is the maximum value you can have in a circle connected to an arrow. So this is 2, 3, and 4, which adds up to 9. This can't be a 4 because we have a 2, 3, 4 triplet in row 7. Therefore, that makes this a 5, which makes this a 9. This can no longer be 1 or 3. Therefore, this is a 2. If this were 2 and 3, this would at minimum add up to 10, right? Because you have 2, 3, and 5 that add up to 10. So this cannot be 2 or 3. This has to be a 1. And we have 5 or 6 here again, which adds up with 8 or 9 there. Now, again, if you have this cell adding up to 3, which is the same as the sum of these 3 digits, again, there must be 2 digits from 1, 2, and 3. Well, here we have one of these has to be then a 4, and one of these is a 2 or 3, right? Because otherwise we don't have enough right. If we know there are 2 digits from 1, 2, and 3, there has to be at least 1 digit here from 1, 2, or 3. So there's 2 digits here from 1, 2, or 3. And then we have 2 digits from 2, 3, and 4. That makes a quad set of 1, 2, and 3 with 2, 3, and 4, right? Which means we know the 4 has to be one of these because you cannot have both 2 and 3 here, right? Because that would eliminate all possibilities for these cells to have, that would eliminate 2 possibilities for these cells to have a 1, 2, or 3, and therefore you would only have 1 digit from 1, 2, or 3, which we showed is not possible. So this can, and also we know this can't be 1 or 2 because of this 1 or 2. Therefore, one of these must be from 1, 2, or 3, which means it is a 3. So this cannot be 3 anymore, right? Because we have to have 2 digits here from 1, 2, or 3 to add up to another digit. And one of them has to be here, which means it's a 3. So this can no longer be 3. Therefore, we have a 2, 4, 2, 4 pair here. This must also be from 1, 2, or 3, and it cannot be 3 because those are both 3s, and it cannot be 2 because we have a 2, 4 pair here. Therefore, this must be a 1. And in addition, we know this can't be 4, this can't be 4, and this can't be 6. Therefore, we have a 3, 5, 3, 5 pair here, which adds up with 1 to add up to 9. So this has to be 9 then. This is 3 or 5. This can't be 1. So since this can't be 1, this can't be 2, this can't be 3, which makes this a 5 and makes this a 3. This can no longer be 4 or 5 because it has to be greater than this. This can't be 5 because it has to be less than this. This can't be a 9 anymore because of this number. This can't be this can't be 4 because it has to be less than this digit. And if this was 4, this would not be less than this digit. So this would be 2. This is a 4, which makes this a 3, which makes this a 2. Therefore, this must be a 1 because of the thermometer. These can no longer be 9. These can't be 9. And this can't be 9. Since this can't be 9, this can't be 8. And we're left with this. So, how, let's see, this can't be 5. This can't be 9, so therefore this can't be 8. We know 9 has to be one of these 2 digits. The rest of these digits are 6, 7, and 8. So this is 6, 7, or 8, and this is 6, 7, or 8. If this is 6, this would be 7, and that would be 8, and therefore this would be 7. If this is 7, this would have to be 8, so therefore this would be 6. If this is 8, this would be 7, and therefore this would be 6. Oh, interesting. So this can never be 8, right? So again, if this were 6, this would have to be 7, which would force that to be 8, because you have to always increase on a thermometer. Therefore, this would be 7. If this is 7, this would be 8, and therefore this would only be 6 possible there. If this is 8, this would be 7, and this would have to be 6. So either way, this is a 6 or 7. Therefore, we have a 6, 7, 8 triplet in box 9, which means there cannot be a 6, 7, or 8 in the rest of the box. So this has to be 3, 5, and 9. And we know there's an 8 in one of these two cells because of the triplet in box 9. Therefore, this can never be 8. Let's see. The remaining cells here are 4 through 9. In row 3, the remaining cells here are 4 through 9. The remaining cells here are 4, 6, 7, 8 for these cells. And this is 4, 6, 7, 8. Where is the 2 actually in box 7? Well, it's eliminated by these cells and these cells, therefore it must be here. So this is 2. Do we have anything else? I'm not sure. Where's the cells in... Where's the 1s? In box 1, it has to be one of these two cells. In box 3, it's one of those two cells. In box 5, it's one of these two cells. Therefore, in box 5, the only cells that can be here are 1 and 9. Right? Because if they were any other digit, where could both 1 and 9 be? They would have to both be in the same cell. Therefore, this is a 1-9 pair. Where can 2 be now in box 5? It cannot be any of these cells. Therefore, it must be one of these two. So therefore, this cannot be 2. This must be a 3, which makes this a 4. These can no longer be 3, so we have a 5-9, 5-9 pair in box 9, which eliminates 5 and 9 from the rest of the box. Therefore, this is a 3. Where is the 3 in box 5? It can only be here. So this is 3. Let's see, what other 3s? Where is the 3 in box 7? It cannot be any of these. Therefore, it must be here. So this is 3. Which means we know one of these digits is a 3. Well, the problem is this can't be a 3, and also one of these two digits is a 3. Well, this can't be a 3 because it adds up, it needs 1 and 2 to add up to it to be a 3. Therefore, this cannot be 3. So therefore, this is a 3, which eliminates that as a possibility. We'll celebrate because 3 is in the corner, and therefore this must be the 3 in box 2. So we should have all the 3s now. This cannot be 4 because of this 4. This can't be 4, so this is 5, which makes that a 6, which makes that 7, which makes that 8. So we now have 2, 1, and 6 adding up to 9. This can't be 7 or 8, so it must be 6, which makes that a 7. Therefore, these can't be 7. We now have a 6, 8, 6, 8 pair in row 7, which eliminates 6 and 8 from the rest of the row. Therefore, this can't be 6. This must be 7, which means this can't be 7. This cannot be 6 or 9, and this cannot be 6 or 9 because of the 6 and 9 we just found here. This can't be 6 or 7. We now have a 4, 6, 8 triplet in column 3, which eliminates 4, 6, and 8 from the rest of the column. So therefore, this must be 7. So 7 cannot be either of these two. 8 cannot be either of these two because of this 8. Where is the 8 in row 3? it has to be one of these two cells. And since it's one of those two cells, it cannot be anywhere else in the rest of the box. So this can't be 8. This must be a 4, which means this cannot be 4. So this is 6 and 8. We now have a 6, 8, 6, 8 pair in box 7. So the rest of the box must be 4 and 9. And this can't be 4. Therefore, we have a 5, 8, 5, 8 pair in row 3, which eliminates 5 and 8 from the rest of the row. Therefore, this can't be 5, so this is 7. This can't be 5 or 7, so this must be 4. Now, if this were 1, this would have to add up to 4, because we have 1 and 3. But this can't, so we already have a 4 in box 1. So therefore, this cannot be 1. Therefore, this must be 1, which means this can't be 1. This has to be the 1. And what are these two digits? It must be specifically 6 and 9. This can't be 9 anymore, so this is 4, which makes that 9. This can't be 9, so this is 5, which makes that 9. What do we have remaining here? In row 2, we have 2, 5, and 8 remaining. And 8 cannot be any of these cells, therefore it must be here. So this is an 8, this must be 2 or 5, but this can't be 5. Therefore this is 2, which makes this 5. And the last remaining cell is a 9. We have 2, 4, and 5 remaining here. This can't be 8. So since this can't be 8, this can't be 7. This can't be 7. This can't be 2. Therefore, we know this has to be the 2. This can't be 5 because of this 5. Where is the 4 in box 5? It has to be here because it can't be here. It can't be any of these. Therefore, it must be here. So this is 4. And where is the 2 in box 2? Can't be any of these because of these 2. Therefore, this is a 2. 4 can no longer be here, so this is 5, which makes this a 4. And we're just doing Sudoku now. This is 2 with 6 or 8, and 2 cannot be here, therefore this must be 2. Therefore this must be 6 or 8. We have remaining here 6, 7, and 8, and we have a 6, 8, 6, 8 pair in row 6, which eliminates 6 and 8 from the rest of the row. Therefore, this can't be 6 or 8, it must be 7. And this can't be 6 or 8, so this must be 5, which means this can't be 5, so that's an 8, which makes that a 5. These two digits are specifically 4 and 8, and this can't be 4, so this must be 8, which makes this a 4. These are specifically 6 and 7. We don't have any information about that yet. So this is 6 or 7. This, not 6 or 9, 6 or 7. We have a 6, 7, 6, 7 pair now in row 5, which eliminates 6 and 7 from the rest of the row. So therefore, this now must be an 8, which makes that a 6, which makes that an 8, which makes that a 6, which makes this an 8. Therefore, this is 6 or 7 because of the remaining cells, and this can't be 9 either because of that 9. So this is 1, this is 9. This can't be 6, so this must be 7, which makes that 6, which makes this 7, which makes that 6. The remaining cells here are 4 and 7, and this can't be 4, so this is 7, which makes that 4. Remaining cells here are 1 and 8, but this can't be 1, so this is 8, this is 1. Which makes this not an 8, so this is 6, this is 8, and now we just finish it off, and that's the 6, and this is a 5. And that's how you solve Storm Surge. Actually, I would consider this probably on the easy spectrum. It was not that difficult to figure it out, especially if you use the thermometers the way that I usually use them. Some people don't like doing that because they don't like more digits on the thermometers, but for me it allows me to visualize things much easier, right? So everything just sort of flowed from what basically getting the thermometer values and then basically realizing what the arrows had to what the 3-digit arrows had to provide, right? Pretty cool puzzle, very straightforward, I felt. I would consider this probably easy level difficulty, but others might uh, think this is a little harder. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.